Hello and welcome to my channel. Today we'll be discussing integration. Straight to the point, integration is divided into two parts. We have the definite and the indefinite integrals. For the definite integrals, we are integrating a function with respect to limits or with given limits. While for the indefinite, there are no given limits. And for the indefinite, you are going to get the antiderivative plus a constant. That's what I wrote down here. Now we also have basic integral rules. Now the first rule is the integration of a constant. So a here is a constant. When you integrate a with respect to x, you're having ax plus c. So using a real number, 2. So if we say integral 2 dx, this is going to give us 2x plus c. Now, note from indices that x power 0 is 1, 2 power 0 is 1, y power 0 is 1. So, because of that, we know that this 2 here has or carries an x that is raised to the power of 0. So let's do that now with x inclusive so that you see what I'm saying. So if this is integral 2x raised to the power of 0 dx, note that power 0 is 1 dx. Let's put that. Note x power 0 equals to what? 1. So if that is the case, it means integral of 2x power 0 dx should be equal to 2x power 0 plus 1 all over 0 plus 1 plus c. So this becomes 2x power 0 plus 1, or 0 plus 1 rather, should give us 1. All over 0 plus 1 is 1 plus c. So this should leave us with 2x, because power 1 is different, is the same thing rather to say as a normal x, and anything divided by 1 is still the same thing. So we add our c, and that is the answer. Straightforward. So, for rule number 2, you can always pause the video or replay. Now, normally, for you to integrate anything, it starts this way. Integral of x raised to the power of n dx equals x raised to the power of n plus 1 all over n plus 1 plus c. So this is the basic or the major rule for integration. The integration of a function. So from this point, we can now form other questions like if we have integral 2x dx. So this is going to give us 2x, this x raised to the power of 1 plus 1, because initially this one is already raised to the power of 1. So we'll be dividing this with 1 plus 1. So this, plus c. So this should be equal to 2x, 1 plus 1 is 2, all over what? 2. So these 2 cancels out these 2 plus c. So this should give us what? 2. There's no 2 again. This should give us x squared. So if you integrate x, you get x squared. If you integrate 2x, rather, you get x squared. So there are many integrals that are like this, but this is the simplest form of expression. So let's do more examples. So let's say we have integral of 4x squared dx. This is going to be 4x power 2 plus 1 all over 2 plus 1 plus c. So this is equal to 4x power 3 over 3 plus c. And this is our answer. Straightforward. Then, if we have let's say 6x or 6x squared plus 2x dx, this should give us 6x squared plus 1 all over 2 plus 1 plus 2x, there's a power 1 here, so it's going to be 1 plus 1 all over 1 plus 1 plus c. So this will give us 6x cubed all over 3 plus 2x squared over 2 plus c. So this should be equal to 6 can go in 3 here, or 3 can go in 6 to give us 2x cubed plus 2 cancels out, we have x squared plus c, and that is the answer. So it is simple and straightforward. So let's do more examples. If we have integral of let's say we have 4x cubed minus 9x squared minus 2x dx. To solve this is simple. This is going to be 4x cubed plus 1 over 3 plus 1 minus 9x squared plus 1 over 2 plus 1 minus 2x raised to the power of 1 plus 1 all over 1 plus 1 plus c. So this is going to give us 4x power 4 all over 4 minus 9x power 3 over 3 minus 2x power 2 over 2. So this cancels out. This is x power 4 minus 3 here is 3. So this is x cubed minus this goes out. We have x squared plus c. This is our answer. So this is all under rule number 1. So now let's discuss rule number 2. Rule number 2 says the integral of a reciprocal function dx should be equal to the natural log that you call lim, the absolute value of the function plus c. And you can also have it in form of the integral 1 ax plus b, where a and b are constants, and a here is the coefficient of x, the variable vx. In this case, it's more like you finding the derivative of the denominator. So if you find the derivative of the denominator, you'll be having a alone because b is a constant. If you differentiate a constant, you get 0. If you differentiate a variable that is raised to the power of 1, it's going to vanish, leaving a coefficient behind. So in this case, this should give us 1 over a, the natural log, absolute value of ax plus b plus c. So this is rule number 2. So let's use an example. So if we have integral 1 over 3x dx, according to this rule, this should be equal to 1 over 3 the lim of x plus c. Simple. So for 2, let's do something that will look like this. If we have integral of 2 over, let's say 5x plus 3 dx. How do we solve this? Just say this is equal to, we bring out 2 and 5. So this is going to be 2 over 5. The natural log, absolute value of 5x plus 3 plus c. So for now, we are handling these 2 rules. The rule for the constant and the variable, and the rule for the reciprocal function. So this is the end of today's class. We'll continue next time, but I want you to subscribe if this is your first time of engaging with my content. Subscribe and click the notification bell for more videos. Thank you and bye bye.